Welcome back everyone to West Explains Best. Today we're going to be doing a Khan Academy tutorial on rationalizing the denominator. So let's go ahead and get started. The first question jumps right into it and it says, which of the following is the rationalized form of the square root of 14 over the square root of 27? So before we do anything, we kind of need to understand what does it mean to rationalize the square root. So before the time of calculators, etc., dividing by an irrational number or a radical was very difficult, and it was much easier to have to divide by an integer. So what they tried to do is they changed how it looked in order to have something that was easier to manipulate and to divide. So one thing that you guys will probably agree on is if I multiply this expression by 1, which I can write as 1 over 1, the value will not change. It will still stay the same as 1 over the square root of 2. Now, I can change how this 1 looks, as I showed before. I can have it be 1 over 1 and the value is still the same. 1 over the square root of 2 times 1 is still 1 over the square root of 2. Now, what happens if I change how this number 1 looks? What if I made it the square root of 2 divided by the square root of 2? Now, you'll probably agree that the square root of 2 divided by the square root of 2 equals 1. Anything divided by itself is 1. So if I multiply anything by 1, we're good. It doesn't change the value of the expression. So this is still a true statement. Now the only difference is multiply by square root of 2 over the square root of 2 will change how it looks. So it is important to see what that difference does. Okay, so let me erase this blue line here and then we'll get started. So it's not going to look like 1 over square root of 2 anymore. It's going to be the same value, but it won't look like it. What will it be? Well, let's multiply the denominators first. So the rules of fractions multiply the top times top, bottom times bottom. So we have the square root of, and we multiply 2 times 2 inside. And then top we have 1 times radical 2. Square root of 2 times 1 is just the square root of 2. And we have square root of 2 times 2, that's the square root of 4. So we can simplify the bottom. The square root of 4 we know is 2. And there we have it. This is the same value as the original expression, 1 over square root of 2. We changed how it looks. So one thing to keep in mind also, this process here of multiplying the square root of 2 times the square root of 2, essentially it will follow the same rule. If we multiply any square root times itself, it undoes the square root and you're just going to get the number underneath. That's really important for when we simplify and rationalize more complicated examples. Okay, so the problem at hand is square root of 14 over the square root of 27. The first instinct may be to just do this: square root of 14, square root of 27, to multiply the square root of 27 over the square root of 27. And you would not be wrong doing this. However, multiplying 14 times 27, if you don't have a calculator, this could be a little problematic and it'd take a little bit of time. So what we're going to do is we are going to simplify the radicals first, if possible. So simplify first, and then rationalize. Rationalize second. Okay, so if possible, we want to simplify first, rationalize second. If we're looking at the square root of 14, this cannot be simplified. How do I know that? There's no perfect squares that fit into 14. And if I did the factor tree, you'll see that its only factors are prime numbers, 2 and 7. Let's look at the square root of 27. Does this have any perfect square factors? So square root of 27, what I like to do to see if it can be simplified, the radical expression can be simplified, is I divide by a prime number. So I get 3 and 9. I can divide that further by 3 and 3. Now you'll probably notice that 9 is a perfect square. Okay, so if 9 is a perfect square, then this can be simplified. If it has a perfect square as a factor, it can be simplified. And I have a video on how to do this also, but essentially what you're doing is you're looking for pairs of numbers. We have a 3 and a 3, so the number that leaves the radical is the number 3. And one of the 3's stays inside the radical. I like to say if the 3's have a date, they get to leave the house, and if they don't, they have to stay home. So we have 3, one of the 3's left, and inside you're left with a radical 3. So we can rewrite this entire expression as the square root of 14. We saw that we couldn't simplify that, over 3 times radical 3. Now we have a much easier radical to deal with. What do we multiply by? We don't multiply. A common mistake I see, well, it's not a mistake, but it definitely makes your life a little bit more difficult, is multiplying by 3 radical 3. You'd not be wrong because this is still equal to 1, but you'd be wasting your time. It's much easier because much easier to do this following method because the only thing we need to worry about is the radical. The radical 3 is the only thing we're trying to rationalize, so that's the only thing you need to multiply by the bottom. But what you multiply it by to the bottom, you also need to multiply it to the top. So we're going to multiply the top times top, bottom times bottom. And we get square root of 14 times 3. We're going to multiply inside the radical. We have 14 times 3, which is 42. Over 3 times radical 3 times radical 3. Well, the two radical 3's times each other equal 3. So we have 3 times, and then radical 3 times radical 3, radical 9, or 3. So now we have the square root of 42 over 9. Square root of 42 cannot be simplified any further. We have 7, 6, 2, 3. There's no pairs of numbers, so all of these stay home. This radical cannot be simplified. So your final answer is square root of 42 over 9. Square root of 42 over 9, option D. Next question. When the denominator of radical 2 over radical 3 is rationalized, it becomes... So let's go ahead and simplify the radical. This one's much easier. So we can multiply radical 3 over radical 3. You're not multiplying radical 2. It's okay for there to be a radical in the top. So we have radical 3 times radical 3. The whole point of this is so that we could just undo the radical sign and we get 3 in the bottom. Now we multiply inside the radicals at the top, radical 6. So it's asking for the value of k. Since k is inside the radical, the answer is going to be 6. Square root of 6. Okay, it's not looking for what is the value of square root of k. It's just asking for k, so the answer is 6. Next question. Which of the following operations can be performed to rationalize the square root of 10 divided by square root of 13? Well, we know that we're only concerned with the denominator, so we're going to multiply both the top and the bottom of the fraction by radical 13. Final question, which of the following is the rationalized form of radical 48 over radical 14? Well, we already know we can't simplify radical 14. It only has prime numbers as factors, no perfect squares. But square root of 48 we'll need to discover. So I'm going to divide it by prime numbers and get a factor tree. 2 and 24, 2 and 12, 2 and 6, 2 and 3. I'm going to circle any time I have a pair. And anytime I have a pair, one of those numbers is going to leave the house. Okay? In order to leave the house, you have to have a date. And if not, you need to stay home. So the 3 needs to stay home. So what does this look like? Well, it means it's 2 times 2 times radical 3. What do I have in the bottom? Well, radical 14 needs to stay. So the first thing I did was simplify. So 4 radical 3 over radical 14. So now I need to multiply by radical 14 over radical 14. This is the same thing as multiplying by 1, but I just changed how it looks. It's the same thing as multiplying by 1 over 1. So what happens? Well, radical 14 times radical 14 equals 14. Then I have the 4. That's going to stay out in front. There's no other coefficients. And then I multiply radical 3 times radical 14 at the top. We've already determined that that's 42. 42 cannot be simplified, as you saw in the previous problem. So now we can just simplify the coefficients if possible. We can cancel 4 with the 14, leaving you 2 and 7. I reduced both by 2, divided both by 2. So our final answer is 2 radical 42 over 7. So I'm going to look for that answer. Option B. And that's all we have for rationalizing the denominator. Hope you guys enjoyed that video, and I'll see you next time.